Hello everyone and welcome to this video. Today I'm going to speak about basic electricity. So you need to know these basic concepts in electricity because when you are troubleshooting you have to figure out what's wrong with some of the components and why it's not working, because you do deal with electricity to power up these components, to power up the devices, and they need to be powered up, and sometimes something could go wrong and it's not mechanical, so you have to look into the electrical part of it and figure out, is this component working correctly or is it something else? And it's great to know these concepts because they are like one of the main factors, very common on the field, because once you understand how the electricity work, then you will be able to track down and trace back what is wrong in that circuit. So to begin, the three most common concepts for electricity is you're going to have voltage, current, and resistance. Okay? Now, what do each of that means? So electricity is ran, it flows in a conductive material. Okay, so just for example, let's pretend this is a copper wire right here. This copper wire is going to conduct electricity when you power it up, right? So just like the example, you turn on a switch here, and then your light bulb turns on. Right? You turn on the switch, the light bulb goes on. Turn off the switch, the light bulb goes off. So when you turn on that switch, you're running electricity to that light bulb, which turns it on. Okay? So now let's get into how that works. So in electricity, you're going to have a negative and a positive side. Okay? You're going to have a negative and a positive side. And at its very core, you have electrons that run from negative to positive. That's called conventional. Meaning these electrons, the negative side is attracted to the positive side. So it's going to go towards the positive side, these negative electrons, which causes a flow of electricity. And that's how you get from one side to the next. And unconventional, you'll see it could go from positive to negative. And not to get too deep into it, there's a history for that. Pretty much when they first discovered it, electricity, they thought it ran from positive to negative, but really it went from negative to positive. But they kept it positive to negative, so when they're doing math, there's not a lot of negative signs. So, but at its very core, it goes from negative to positive. Okay? So what is a voltage? So the voltage is measured from opposite ends, right? You're going to measure the positive and negative, the negative and the positive, and you're going to find out what your voltage is. And what is a voltage? A voltage, you could think of it like the pressure that's going to be pushing the flow of electrons, right? You have these little electrons running around, going to the positive side, right? It's going this way. Well, if you don't do anything to it, the electrons are just going to sit still and nothing happens. Well, you need something to push it. You need something to push that electrons to go across the way. And that's where voltage come in. Voltage is the pressure, the thing that's pushing those electrons across, okay? Pushing the flow of electrons, which comes up to our next thing is, what is a current? You could look at current as the flow, right? As the voltage is pushing these electrons over, that is the flow. The flow is the current. How much flow is there? How much electrons are in there flowing across that conductor, right? So voltage pushes the electrons, voltage pushes the flow. How hard it's going to push, how fast, it depends how fast and how strong that current is going to go. It's like water, right? That is the current, is the flow of electrons. Now, what is resistance? Well, resistance is what it means. It's going to resist the flow. It's going to resist the flow of current. So it's going to oppose the flow. It's going to slow it down. It's going to stop it. That's what the resistance is, right? So depending on your application, you may need a lot of pressure and a lot of current going into a specific device like a motor. You need something strong to turn that motor on. So you're going to need a lot of voltage, a lot of current. And let's say something like very small, like a light bulb. You don't need that much voltage or current, because you might blow that light bulb up, because the more current you have, the more power it's going to have. So it's either going to be a little bit of electricity or a lot of electricity going into a device or component. So you might want to use resistance in that sense, because you want to slow down the electricity and hit the light bulb at the right amount so that it doesn't blow up and it just illuminates, right? So just to reiterate everything, at the core, you have these electrons going from negative to positive, and in order to get it flowing across the way, to get from one end to the next, you're going to need a voltage which pushes those electrons across. And those electrons that are flowing across is the current. And something that is going to stop the flow of the current or mediate it is going to be the resistance. And these three, concepts are very important in electricity, because it measures, you can calculate how much voltage you need, how much current you need, how much resistance you need, depending on the application. But at the very core, you have voltage, current, and resistance. And just remember that the electrons are flowing when the electricity is active. Okay. And just to give you a visual, a better visual, we could look at it as like water flowing, right? So let's say you have water. You want to pour water into this bucket right here. Okay. You have your pipe flowing. And then you have your water tank. Okay. Now, let's see. Now, so you're trying to pour water into this water tank, right? If you were to fill this water tank full with water, okay, and let's say you have like a little spigot. Okay, if this tank was full of water, when you open that spigot, what happens to that water? Well, since this tank is full, it's going to come a lot out. There's going to be a lot coming out, just full of it, just flowing, right? The minute you open that, it's going to be a whole bunch of water flowing into that pipe and into that bucket. Okay. So you could look at that as voltage. Okay, the pressure that comes out because it's so full. The minute you open it, it's going to pour so much water out because it's so full. There's a lot of pressure in there that needs to be released. Okay. Another example would be, what if you didn't have that much water in there? What if you only had to the very bottom? Okay. So what happens in that case when you open the valve? Since there's little water in here, when you open that valve, not that much water is going to flow out because there's not that much pressure built up. So when you open the valve, it's going to flow slight water coming out, and it might drip because there's no water, because there's no pressure. So that's the voltage. Okay. The current. Oops. The current is the flow of water. Okay, let's draw this water back again. So when you open that valve up, that flow of water is your current. Right there. Just like electricity, electrons are moving this way, the water is flowing to a specific way, but that is your current, is your flow of water, flow of electricity. Okay? Now, let's say at some point in that pipe, you decide, hey, there's too much water, and somebody's not standing at the beginning, they can't they can't close that valve. Let's say somebody's standing on the other end of the pipe, and they say, hey, let's slow down this water. We have too much water coming in. Okay? So they turn the valve and it slows it down. It shuts the valve off. Either shuts it off, or in this situation, resistance usually means impedes. It slows it down, imposes it. Not fully shut it off. You can, but for the most part, it just slows it down, right? So when you turn on this valve over here, it slows down the flow of water, which at the beginning was a lot of water. Since you turn that valve, now it slows it down, and now it's half the amount of water flowing. So that's half the amount of current. So you have so much current, so much flow here. You turn on the resistance, which now slows down the amount of water that's going into that bucket. So to recap, we have the negative side, negative side of the field. We have the positive side of the field. Okay? For electricity, the voltage is the pressure, the current is the flow, resistance is what imposes the flow of current. And to give you an example of the water, we have a built-up pressure of water. Once you release it, it flows. And if you want to mediate the amount of water that's flowing, you turn on the resistance, and that changes the flow of current. So it's very important to know these basic concepts, because when you're on the field and you have to troubleshoot, some devices you have to know. Some devices will be rated 12 volts, and in order to see if that device is working correctly, you have to measure the voltage. You have to say, this thing is rated for 12 volts. If I'm measuring it and it doesn't have 12 volts, then obviously this device is not getting power from somewhere, or the device is not working correctly. Same thing with current. When you have a motor that's pulling current that has like 2 amps, and to work correctly, and then when you're measuring the current, it says, oh well, it's only 1 amp, then you know that device is not pulling correctly and something's wrong in the field. Same thing with resistance. Resistance sometimes is measured to measure the flow. Like we know there should be a flow, right? If you measure resistance and the resistance is high, you have to ask yourself, why is it so high? What's stopping it? What's impeding this flow? And you have to measure resistance. So these are basic concepts that we use a lot on the floor to troubleshoot. And it's good to know how they work at its very core. So when you do troubleshoot, it's easy to understand what's going on. So that is the basic concepts of electricity. Thank you guys for watching this video. If you have any input, please put them below to help others out. If you have any questions, please ask them. Thank you very much. Until next time. Thank you.